Okay then, welcome to another lesson with Mr. D. This is our maths lesson and we're doing fractions, aren't we? A bit of a short lesson today. We won't do a lot of arithmetic and times tables. You guys can go and keep doing times tables, getting some wonderful high scores of 36 and 37, nearly 40 in a minute, which is amazing. I can put some mental maths and arithmetic sheets in the Google Drive that we're going to be using to upload our work to. So if you want to do some more generic questions other than fractions, then upload those and work from those. We're just going to have a quick lesson of fractions, and I'll give you some activities to do. So what is a fraction again? A fraction is just part of the whole. Just keep saying it to yourself. That's all it is. It's nothing tricky. It's nothing complicated. It's just part of your whole, and a whole can be one thing or it can be lots of things together. But as soon as you identify what the whole is, fractions become easy. Fractions are just equal parts of that whole. You'll have to excuse Laura Lily, who's being very naughty. So yeah, let's get straight to it. Where hopefully most of this should be a little recap. So again, pause the video if you want to have a go at this. You can do it in your head, or if you want to work from the screen, you can copy these out yourself. Absolutely fine. So 2, 6 out there. This is a tricky one here because this is the whole, and it wants to shade 2, 6. So they're trying to catch you out here. What are you going to shade basically? A tricky one to start off with. So don't worry that they've split these into thirds, because that would give you 3, 6, 9, 12, 15. That would give you 18 equal parts. And we haven't split it into 18 equal parts, have we? We've split it into 6 equal parts. Our denominator, which tells us the amount of equal parts, is 6. So the 6 refers to each whole circle. And 6 of them together makes the whole, but I would only need to shade in 2 of my 6 parts. Again, here another tricky one. These are just to test your knowledge. So 1, 2, 3, 4, 5, 6. So that's the bar's been split into 20ths, but it wants to show 6/10. So that would be one part. That would be a tenth. That would be another tenth. That would be 3/10, 4/10. I'll try and add notes and take in here. So that's going to be 1/10. That's going to be 2/10. That's going to be 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. That's a bit of a challenge one there. People are wanting to have a challenge. And the fractions are part of your whole. We've got unit fractions, which are when the numerator is 1. We've got non-unit fractions. So a unit fraction could be like this when the numerator is 1. We have non-unit fractions when the numerator is bigger than 1. I'll keep the denominator the same. And then when our numerator and denominator are the same, the top number and the bottom number, that means we have the whole again. Super. So then we're going to look at adding fractions today, and it's really easy. As long as your denominators are the same, you can add across the numerator, and it's simple as that. Where are we? Let's have a look at these. This is just a bit of recap again before we get on. So can you complete the missing information in here? This is what I've just shown on the smart. What does that show? What does that show? this will help you think about adding. So your whole here is all the apples together. So even though there's lots of individual apples, all of them together is your whole. And how many parts there are, how many equal parts, that's your denominator. So there are 1, 2, 3, 4, 5, 6, 7. There are 7 equal parts, and how many parts are red? 4 of my 7 parts are red. How many are green? 3. And then if I've got 4 sevenths, add 3 sevenths, I'm going to get my whole back together again. And this is a nice little challenge one here. Rosie, you're drawing some bar models now to represent the fractions that I'll just cover that out. That's got the answers. How would you fill in the bars to show in 1/2, 1/4, 1/3? Well, this is, you're going to have to add some more bars in here to show 1/3. So I'll do the half one for you. So they've got to be equal, haven't they? I'll do that again. Make my pen a bit bigger. So that's 1 part, and I need 2 parts. And the blue bit is 1 part. For 1/4, I'm going to need to show 4 equal parts. There's 1/4 blue. See if you can fill in the rest. Again, here's a tens frame. This is your whole. Can you show 1/10, 2/10, 3/10? What would these fractions be called? How would you write these as fractions? Yeah, it's a fraction because it's just part of the whole. The whole is the shape. So how would I write that as a fraction? What part is shaded? And we looked at this as well. Hopefully you've seen it. So this is just a part whole model. This is your whole, 10 out of 10 tenths when the numerator denominator is the same. So what 2 parts would make 10 tenths? I have 6 tenths. How many more tenths do I need to get to 10 tenths? Well, I need 4 tenths. I have 1/10 here. So my part, I'm not getting to 10 tenths, so I just need to get to 4 tenths. What do I need to add here? So let's have a look at some questions with relates to adding a fraction. Now I've already said let me get set up here. That adding fractions is super easy because if the denominator is the same, we just need to do some simple adding. So have a look at this in focus task here. This is a chocolate bar. This is your whole. Yeah, and you can quite clearly see that it has been split into 5 equal parts. So they want to share some of it. They might not share all of it. They want to share some of it. This guy's going to have a piece. So if he's having 1 piece of that chocolate bar, what is that as a fraction? Okay, a whole split into 5 pieces, and he just has 1 of those parts. He has 1/5. The girl, she has 2 of those parts. Yeah, the whole is the same, so the denominator is the same, the parts that I split it into is the same, but she has 2 of those pieces. So how much of the chocolate bar, what fraction of the chocolate bar did they eat? Well, if the denominators are the same, I can add the numerators together. 1 part add 2 parts is 3 parts out of the 5 parts that I had. So they had 3 parts. Remember to pause video, go back. If it didn't make sense, go through it again. Keep reading it. Do it, whatever you need to do to make yourself understand. Right then. So each piece is a fifth. Because I split the whole into 5 equal parts, so each piece is a fifth. He has 1/5. She has 2/5. Together they will have 3/5 because 1 and 2 is 3. 1/5 and 2/5 is 3/5. 1 part and 2 parts is 3 parts. Not one of the many ways that you could say. Oh, got a bit too far. Another one. So they haven't done it in chocolate pieces. They've just turned the bits into a bar. But this time it's 2/5 and 2/5 is 2/5 and 2/5. That's right, 2/5 and 2/5 will equal 4/5. Do I have the whole? Have they shared all of the chocolate bar? If they were sharing a chocolate bar, or if they were sharing an orange in 5 pieces, have they shared all of it? No, they haven't shared all of it because I've still got 1/5 left. So there'd still be 1 part to give out to somebody else. Now let's have a go at these together then. 2/7 and 3/7. Now do not be put off by the denominator changing. It does not matter. The denominator is just the parts. We could have split the chocolate bar into 7s. We could have split the class into 7s. We could have split a number into 7s. The denominator is just a different fraction. It's nothing, we don't have to do anything different. So I have 7s, and that's important because the denominators need to be the same in order to do this addition. Then it's my parts that I had 2 and 3. The denominator is going to stay the same because the parts need to be the same. They need to stay the equal parts. If I've got different sizes of parts, then I can't add my numerators. If the denominator is different, then I can't add the numerator. The denominator is the same. They're both 7s. So 2 and 3 is 5. I'm going to have 5 7s. One ninth and 4/9. Then again, doesn't matter that the denominator is different than here. Oh, we're doing this one. Sorry, thirds. Okay, if that's confusing, just looking at it like a fraction model here, let's think of it as that bar model, or we could probably think about it as that more rough thirds picture. Some people prefer looking at pictures. So if it was the bar model, then I need to split my bar into 3 equal parts. So that's a third, that's a third, and that's a third. It's a circle, which most people are familiar with seeing. It looks something like this. That's a third, that's a third, and that is a third. And all it's saying is 1/3 add another third. Well, how many do I have? I've got 1, 2, 2/3. It's as simple as that. Really, really simple. have a go at the rest. This last one looks tricky, but the sum, you'll know the sum is just another word for add, and we're just adding across 3 numerators. Remember, if the denominator is the same, then you can just add the numerators. Common misconception, common trip that some students get is that they add the denominator together. Now you wouldn't add the denominators together because that would change the whole. So the parts stay the same, so the thirds, they stay the same. Don't add the denominators. You just add the amount of parts that you have. So you've got 1/3, treat it as 1 part. Yeah. So here you're not going to get 33 as your denominator because you never had 33 parts to begin with. You only split it into 11 equal parts. Here's a worksheet for you guys to have a go at. So the pizza was cut into 10 equal slices, so that means that they have tenths. The whole pizza was cut into 10 slices, so I have tenths. He ate 2, he ate 3. How much did they eat altogether? There's some more to do there. Pause the video there and have a go, write them into your book, copy them down. I'll give you the answers. You've had a go. The answers there to double check. Try not to wait for the answers, have a go yourself first. Right then, and just a few more for those people that want a bit of extra challenge. If you want to do another lot, please do. One slice, add 3 slices. I'm going to whiz through this because it's really not that tricky. If the denominator is the same, you can add the numerators together, and you do not add the denominator. 1/4, add another 3/4 is going to be, I've got my whole again, haven't I? I've had 1/4, adding another 3/4, and I've got 4/4 again, or 1 whole. I prefer writing 1 whole than just 1 because we weren't looking at the number 1, we were looking at a pizza. Yeah, you can split 20 into 1/4 and 3/4, and the answer wouldn't be 1, it would be 20. So 1 whole, I prefer that. So when the denominator and the numerator are the same, you've got your whole again, haven't you? So here we're adding again, so we need to make sure that the denominator is the same. 1/6 and 3/6. There's this bar model again. This is your whole. The bar is split into 6. 1, 2, 3, 4, 5, 6. 1/6 add 3/6 is 4/6. Do you have your whole this time? No, because the numerator is different from the denominator. How many parts do you have left? Well, we have 4/6. I've got 2 more 6 to make my whole. Again, I'll leave you guys to have a go at these. If you're getting it wrong, I can imagine that you're adding the denominator. We've said do not add the denominators. The parts have to stay the same. It's the amount of parts you have that we're going to change. And then some more for you guys to get on with. Here are the answers. And that's what I'll leave it for today, so you guys can finish adding fractions. Let me know how you're getting on, and I will help you where I can. Happy maths. I'll see you next time. Bye-bye.